Now we're going to look at compound inequalities. And a compound inequality just means more than one. So two inequalities joined by the word and or the word or are called compound inequalities. A conjunction is a compound sentence formed using the word and I will usually refer to these as the and inequalities. The solution of a conjunction is the intersection of the solution sets of the individual sentences. A disjunction is a compound sentence formed using the word or, and again I will usually refer to those as ors. The solution of a disjunction is the union of the solution sets of the individual sentences. Now let's actually look at graphing, and these are going to be examples of and compound inequalities. So as you can see, two of them actually use the word and this one is written in a different format. And inequalities are the only type that we can write as one sentence like this, with one variable but two inequality symbols. We're not used to seeing that. But it does mean the same as putting the word and in there and writing two separate. In fact, if you were to cover up this part of the inequality, you would say x is less than or equal to 5. And if we covered up this part, we would say x is greater than or equal to -2, and we would put the word and in between. So if I'm going to graph this, I'm going to have brackets at -2 and at 5. I need to be less than or equal to 5, so 1, 2, 3, 4, so this would be 5. And -2 is right here. And I need to be greater than or equal to that. We always read our inequality symbol with the variable coming first. So x is less than or equal to 5 and x is greater than or equal to -2. And we are going to shade in between. All of these numbers fit that criteria of being greater than or equal to -2 and at the same time less than or equal to 5. When we look at the compound inequalities that actually have the word and in them, we would graph them the same way. M is greater than -2, so again here's -2, and M is less than or equal to 6. Since I'm just letting them all equal 1, I actually go off my number line a little bit there. So again, read from the variable coming first. So M is less than or equal to 6, so that's a bracket. Greater than -2, that's a parenthesis. And numbers that meet the criteria are in between. So greater than -2, less than or equal to -6. So now let's look at less than 5. Would be a parenthesis, and we want greater than or equal to 2. That's a bracket at 2, and the numbers in between. So now how would we actually solve an inequality that's written all in one sentence? Well, what we would do if we didn't have that first part of the -4, you would probably look at this and go, oh, well, I would just add 5 to both sides. But since we're dealing with an inequality and it's not both sides, there's actually 3 parts to this inequality. We have to add 5 to all 3 parts. When we do that, we get x all by itself because the -5 and the +5. 3 and 5 is 8. -4 and 5 is 1. So our answer is x is less than 8 and greater than or equal to 1. So I'm going to disregard my 0 there. I'm not going to have that be 0. I'm going to have this number be 8, which makes this one number 1, which would make this one 0. So if I want greater than or equal to 1, that's going to be a square bracket. And if I want less than 8, that is a parenthesis. and I shade in between. And all the numbers that fall in between are solutions to my compound inequality. Now let's look at some OR inequalities. So in the first one, t is less than 0, so less than 0 would indicate a parenthesis and shading to the left, or greater than 5. And here's 5 here. So I'm not shading in between this time because all the numbers that are less than 0 go this way, and all the numbers that are greater than 5 are going this way. So our graphs actually go away from each other when you're dealing with the ORs. With the ANDs, your solutions have to fit both criteria, and that's why they would fall in between. But with ORs, it's one or the other. In fact, if this word said, or if the word was AND instead of OR, we would say there's no solution because there is no number that is less than 0 and at the same time greater than 5. So that's why it uses the word OR. Let's look at the next one. Y is greater than or equal to -2. So that's going to be a bracket opening to the right. Now the next one has -y less than or equal to, greater than or equal to 3. So we would need to, first of all, solve for that. Divide by -1, which is going to give us y less than or equal to -3, because you have to reverse your symbol. And so that's going to be here. So we need less than -3, and we need greater than -2. Now let's look at the last one, greater than or equal to -3. Shaded to the right. And then we have a greater than or equal to -1. So that seems kind of strange, but I'm going to do it in a different color so you can see it. It's also shaded to the right. Now we didn't do anything wrong, but both our graphs are going in the same direction. Well, since I can be one or the other, then what I originally had in purple would actually include everything that's greater than or equal to -3, and part of that is also everything that's in blue, which is greater than or equal to -1. So my purple graph would be the solution. If the word was AND, it would have to meet both criteria, and so where the purple and the blue overlap would be the solution if it was an AND. But since it's an OR, it can go all the way down to -3, so I can actually just back that off there, the blue, and that is my final answer. Now let's look at graphing some ORs. Also notice that we can't put ORs in one sentence like we can ANDs, so we can't write them with two different inequalities, and that's because their graphs would go in opposite directions, and so would their inequality symbols, and so they have to be going the same direction in order for us to do that. Let's solve this. So I have to solve them individually. So 2z plus 3 greater than or equal to -5. I'll solve this one first. So I have to subtract 3 from both sides. That's going to leave me 2z greater than or equal to -8. Divide both sides by 2. That's going to leave me z greater than or equal to -4. -4 is right here, and we want greater than. Okay, so now let's look at the other one. 6z minus 7 less than 11. Add 7 to both sides. 6z less than 18. Divide by 6. Z is less than 3. So less than 3, let's see here, 1, 2, 3. And this is starting to look a little strange also. So I'm glad I did it in 2 different colors so we can look and see what we have going on here. Now on this one, if this was an AND situation, then what's in between the bracket and the parenthesis would be our solution, because those numbers meet both criteria at the same time. But since it's an OR, it can either be on the blue line or the purple line. Well, since they do overlap, that means it could be any number